Um, Good afternoon, guys. Today I'm going to look at our last two properties for the indirect utility function. And the one that we are looking at is decreasing in price and satisfying Roy's identity. So when we say decreasing in prices, what we're saying is that if supposing your price changes, let's say you go to market and your price has increases, right? So once your price has increased, then what it means is that we expect you to buy less of what you bought before the price increased. Now, once you are buying less of what you previously purchased, then what it means is that your maximum utility is going to be reduced. So it has the indirect utility has the property that it's always decreasing in price. Anytime that your price is increased, we expect it to what? Your maximum utility to decrease. So let's start again. And as we always do, we're going to use our algebra to explain it again. So we first said our indirect utility function, which is always the same as what? Utility, which is replaced with the optimal x, which is a function of p and y. So if I differentiate v, okay, so in this case, I'm proving that it's increasing in what? P. So if I differentiate v with respect to p, it is going to be, because this s consists of I up to n, summation of I equals to 1 up to n, right? Then du dxi, du dxi multiplied by the xi, the pi. Great, it's okay. Now from the same first order condition, you remember du dxi is equals to what? From the first order condition, lambda pi. That is from the first order condition, right? So that I can say the v with a function of p and y, with a function of p and y, dp is equals to summation of I equals to 1 up to n lambda pi, and then multiplied by the xi, the pi, right? So I can take the lambda out because it's like a constant term, and that will give me dv dy is equals to lambda into bracket summation of I equals to 1 up to n pi dxi dp, right? So we are looking at the influence of changing price on a certain commodity, right? So first of all, let's go back to our budget constraints. So I'll say P1 X1 plus P2 X2 plus PI XI plus PN SN should be equal to Y. So I'm differentiating this respect to what? XI. So this is going to give me P1 differentiate X1 respect to PI plus P2 differentiate X2 respect to DPI, right? Plus, but when I get to this point, I will have to apply the product rule. Is okay? So I'm going to have, I hold X1, XI, I differentiate respect to PI. So when I differentiate PI respect to PI, that gives me 1. So that means I'll have plus XI. Is okay. Plus, then I hold PI. Then I differentiate XI with respect to PI. So I just use the product rule to differentiate this one, plus Pn dxn dpi is okay. But when you differentiate y respect to pi is equal to 0, because your income does not, the price of money does not change your income, but the prices can influence the quantity of x1, x2 that you purchase. It's okay. You go to market with your income. You know you have your income in your hand. You go there. If price changes, it doesn't change your income. Your income is always 0. But if price changes, it can change the quantity of S1, S2 that you are going to buy. It's okay. Yeah, so when I sum up this expression, I'm going to have it as well summation of I equals to 1 up to n pi dxi over pi, right, equals to, sorry, so let me make this one sd. The sd is equals to plus, sorry, plus xi is equals to 0, right? Then that implies that summation of I equals to 1, I equals to 1 pi the sd dpi is equals to minus xi, which is a function of p and then what, y. Is okay. So great. So this is xi. So what it means is that in place of this expression, I can write minus x, right? So that means that the dp is equals to what, minus lambda x p of y. X is a function of p and y, which is less than what, 0. So it's true. It is what is decreasing in p. So let's look at our indirect utility function again. We had v, which was a function of py, which was equals to y into brackets p1 r plus p2 r minus 1 over r is okay. So when I differentiate v respect to, when I differentiate v with respect to p, right, I'm going to have this expression come here, minus y multiplied by 1 over r into brackets p1 r plus p2 r, then minus 1 over r. You subtract 1 from 8, is okay. Then you differentiate what you have in the bracket here, which is going to give you I'm differentiating to p1, is okay. It's going to give you r p1 r minus 1. So this r cancels this r. Then I'll have it as what? Minus y into bracket p1r plus p2r minus 1 over r minus 1 p1r minus 1. And because it's negative, it's true, it's less than 0, right? So that means, yes, the indirect utility function that we solved for in our tutorial session 2 holds for this expression, is okay. Now the next one that we are looking at is the Royce identity. Now the Royce identity is saying that when you have your indirect utility function, you can as well derive your Machiavellian demand function from it. Anytime that you have your indirect utility function, you can derive your Machiavellian demand function from it. Now, this is the expression that they use according to the Royce identity. X py is equals to minus the v, the pi all over the v, the income. So let's say if I'm looking for x1 py, then I'm supposed to have what, differentiate the indirect utility function with a function of p and then y respect to p1, because I'm looking for x1 all over differentiate respect to income, which is y, right? So let's try from what we did. You know that when we differentiated v1, right, the py to the p, which we just did, we had this as what, minus lambda x, right? And when we differentiated when we differentiated income v respect to income, we also had it as what, lambda, right? So this cancels this. then you have minus x. So that is true. X, which is a function of py, is equals to minus, there's already minus here, right? There's already minus. So it's going to be minus minus, which makes it positive, right? Which makes it positive. So you're going to have equals what? X, which is true. Is okay, which is true. XPY. So it is true. Now we can as well try with what we just did. We can just look at you can try this using to check whether it holds. You can try this using the indirect utility function that we have already solved for, which is this one. Which is this one. Okay, what is it? Yeah, this is the indirect utility function that we have for first. So when you differentiate respect to income, that will give you only this expression here. Then you can again differentiate respect to what? Price. If I'm looking for the P1, I differentiate respect to P1. Now, once I divide the two equations, I'm supposed to have what? My X is okay. Thank you very much. Do not forget to subscribe to my channel.